Welcome to the part 2 of the volume of fluid simulation tutorial with OpenFoam. In this tutorial, in this part 2, I'm going to show you how to mesh the geometry of our simulation. You can download the files of the example which we are working from the link in the comments. If you just want to run the mesh, you can just open the file and run the run/mesh script. If you want to see the part 1 of this tutorial, please click on the link above. Now we can see the overview of the simulation we are working, and in this part we will be addressing the meshing, as I said, and this involves showing the CAD in FreeCad, which is a completely free software for CAD manipulation, and we will then proceed to do the block mesh dict and then the snappy hex mesh dict. Here is our computational domain, which is composed by two geometric objects, a wall with a hole representing the dam break, and here some wave breakers, so to say. The wireframe box represents the whole computational domain where these geometric objects will be integrated, and the computational domain we will generate in block mesh dict. Please feel free to add any additional geometric objects you liked or modify the existing ones. When you are finished, just click on both bodies and export them as STL binary file. After saving the STL file, you just have to put it in the right directory. The directory is your OpenFoam simulation constant 3 surface. The name of the file should be, if you're using this example, box3.stl. Here is the block mesh dict file. You can adjust the size of the computational domain box by changing the parameters of the minimal and max XYZ coordinates, and then you can adjust the resolution of the computational domain by changing the number of cells. I recommend you to start with a lower resolution and then increase if you want to have more accuracy. I don't recommend to touch any other parameters in the file, since that would just probably cause problems. You can see here the snappy hex mesh dictionary file. As you can see, we're going to have a castellated mesh with snapped geometry, and we're not going to add boundary layers for the moment. The geometry we're going to use was the previously generated CAD, which in our case is an STL file named box3. The rest of the parameters should allow us to run the simulation smoothly. Feel free to change any parameters you like. For example, you can change the the level of refinements of the surface mesh. If you like this video, please like, comment, subscribe. We will soon be releasing part 3 of this VOF simulation tutorial with OpenFoam.